Charcha on nanotechnology. This event is jointly organized by IEEE NTC WIN, IEEE Nano NTC Student Branch Chapter IIT Indore, along with IEEE Madhya Pradesh section. So today our distinguished speaker, Dr. Prabha Sundaravadivel. She is an assistant professor at University of Texas, Taylor, USA. Now I would like to briefly introduce her. So, Dr. Prabha earned her Bachelor in Electronics and Communication from SRM University, Chennai, India in 2011. After she has done Masters in VLSI Design from VIT University, India in 2015. Before starting her PhD, she was at the Smart Electronic System Laboratory in University of North Texas. She has she has received her PhD in Computer Science and Engineering at the University of North Texas in 2018. Currently, she is employed as an assistant professor in the Department of Electrical Engineering at University of Texas, Taylor since fall 2018. She manages a diverse group of grade, undergrad, and high school student researcher as the director of Intelligence System Laboratory at University of Taylor. Her research interests are focused on developing application-specific architectures for smart healthcare and smart cities, is intelligent embedded system for IoT applications, human-computer interaction, reconfigurable computing, augmented reality for smart healthcare, robotics, and machine learning. She has been involved in various outreach activities in East Texas to broaden the participation in STEM. She founded the student organization IoT Student Club to improve the implementation skills of undergraduate students. She has been associated with many reputed conferences such as Richard Tavia Celebration for Women in Computing, which is held in 2022, and Grace Hopper Celebration for Women in Computing, which was held in 2019. She has also received Teaching and Learning Award 2019 for introducing innovative teaching techniques in the undergraduate curriculum. Now, I would request to our distinguished speaker, Dr. Prabha ma'am, please start your talk.
Thank you, sir. Thank you for the kind invitation. I greatly appreciate it. And thank you, Dr. Pavan, for inviting me and for this opportunity. Let me share my screen.
Yes, ma'am. Now you can share your screen.
Sure. I hope everyone is able to see my slideshow.
Yeah, it is visible for us.
Okay. Hello, everyone. Today I'm going to talk about our research, particularly on the end effectors in the when we are talking about all this IoT frameworks, robotics, and all that. What is the final device that actually interacts with us, right? Which is collecting the data and all that. Because Dr. Pavan had invited me, I am assuming that most of you have some background in the sensors side. So let's talk about like what makes from the sensors what it takes to build the IoT framework or the robotics framework as such. And that was a very kind introduction. Thank you so much. I'm a faculty at UT Taylor, as sir mentioned. I'm also running a lab named Intelligent Systems Lab. In our lab, we are working on Internet of Things frameworks for specific applications for smart healthcare or smart transportation. And in particular, in the past couple of years, we have gotten some projects on underwater systems and also on the robotics. We are working with the local city to develop some proof of concept robotic frameworks to basically improve the curriculum on all the smart devices. And we are working on bio-inspired soft robotics, which is very closely aligned to how to have these stretchable sensors and biomimicry of existing living organisms, so that we can have the robotics that we think about is not the traditional humanoid robots as such, right? We have funded projects from NSF, the National Science Foundation, Oracle for Research, NASA Scope, and VentureBills to for all these different projects. So this is my group at UT Tyler. We have fully equipped IoT workstations, and in our lab we do some soldering, 3D printing, and we have an assembly station as such. And we have a underwater test bed where we have large tanks. We have access to those tanks through my collaborator. We have these large tanks where they have set it up as freshwater steams. That really helps us in building these robots and testing it before actually sending it out. And we are also creating a robotic test arena for multiple texture and everything. All right, let's get into the actual core of this one, right? What do we mean by things in the smart cities? When you talk about, when for those of you who are not familiar with IoT frameworks or who are trying to learn more about it, you would have heard this buzzword Internet of Things everywhere, right? So IoT, which means collection of these individual devices, is nothing but when you actually connect a sensor and make them talk to each other, when you form a network of sensors or actuators that can talk to each other, we have Internet of Things. Let me show you all an example. Here we are seeing an example of smart street lights where we actually connected the solar panel along with the motion detection sensor. And the main research challenge here is that we need to make this portable device work in the as part of existing street light infrastructure, right? So street lights, as you know, they would have the steel or just the wood and like log to hold it. So how do we actually put a smart device around there? Because imagine we are not going to have any Wi-Fi capability there. We are not going to have a Bluetooth as such. So how to make these devices actually collect this data and send it to us? So basically, what we did here is we found a collection of networks between these different streetlight infrastructures, and we were trying to collect the data of light intensity. So the physical quantity that is converted into a data point is nothing but the light intensity. So based upon whether how well lit the area is, we will in case here in Texas we have daylight saving, and in the summers we have like lights go we have the sunlight until 9 o'clock in the night, right? And there are winters where even at like 4 o'clock it just darkens up. So it is, we cannot set a standard time, or at least so far there is a standard time at which the street lights go on, so there is a problem. So we are trying to do this. Actually, interestingly, in this problem we got in hand through my collaborator from traffic engineering, who was doing some data modeling on uh, what is a major reason for crashes in all these small towns. And then we got to know that there were a lot of data points on crashes where they were saying that the area was not well illuminated, right? So that's why we started monitoring, automating the light intensity monitoring in here. In our other research for underwater sensors, we developed a lightweight turbidity sensor where right now whatever the turbidity sensors we would see for as part of the underwater frameworks are these big sondes or big floats, right? That can have these sensors equipped with that. So our challenge was to how to miniaturize it or how to effectively use it without spending thousands of dollars on those big machines, right? So when we were looking into this problem, what we analyzed is all it took was to identify the right LED and place it in a certain angle in such a way that when there was light passed through that water in that target area of water, based upon how much the light gets reflected, you can actually we can actually like calibrate the quality of the water. So there are certain formulas associated with it. So based upon the light intensity of how much it gets reflected, we were able to come up with a lightweight turbidity sensor. So this work we published in the Oceans Conference last year. So in both the research, one thing is common here, right? In both, we are actually measuring the light intensity. For the street lights, also for automation of like when it has to go on and off, we are measuring the light intensity. And here also we are measuring the light intensity for the turbidity sensing. So what the physical quantity we are converting is the same, it's a light intensity, but the way it is actually conceived as a data point, that is different, and that is what is the IoT framework. So in IoT framework, what we try to do is the physical quantity, whatever you are measuring, you can measure the same temperature, you can use the temperature sensor for different kinds of applications, right? You can use a temperature sensor as part of a wearable, as part of a home monitoring system, or as part of climate monitoring system, or the sprinkler automation, whatever you can think about, right? So we are trying to integrate these sensors or actuators to microcontroller unit or a single board computers, which can help in making it a thing that can talk to each other, and we are collectively forming a sensing network. With help of low power gateway, we are sending it to the cloud, usually where all this data analytics happens, and we can come up with predictive models. Like I said, in that smart street lights, when we are talking about an automation process in such a scenario, we need to see, okay, as per the sunset, when can we actually start having the street light switched on, right? So that is our modeling, that is our data analytics in there, where also we can store large amounts of data to come up with these trend analysis in there, right? And after doing all this, we usually give the feedback to the user with the help of a mobile application or a user interface, which is usually like just a simple HTML based web page. If you are having access to all these expensive cloud infrastructures like Amazon, AWS, or Microsoft Azure, and so on, you can use uh, that cloud service itself, where you can also have a option to create an app to give the feedback to the user as such, right? So in our research, in our research group, what we are trying to do is we are trying to bring this sensing network and the whatever the performance happens in the cloud together. So this is what we are calling as edge intelligence, where we are saying that instead of merely connecting a sensor or an actuator to a microcontroller unit and sending all the data to the cloud, why can't we bring some of this part to the monitoring side itself? So we are trying to close this gap, and mainly we are trying to do this because we are approaching problems where there is a limitation in terms of connectivity, like the underwater sensing. The main challenge is that we cannot send the data at least close to real time, right? With the available communication protocols. We can, in case like if you are having access to all those expensive frameworks, but we are trying to come up with low cost frameworks for these things. And also like we are trying to see if we can implement all the smart technologies in the rural environment, right, where there is already a limitation of Wi-Fi or I'm so sorry, Wi-Fi or the Bluetooth and all those things. So when I'm saying that there is a limitation in the actual connectivity in there, let me give you all an example. What you see here is all these different smart healthcare products, right? It can be a smartwatch, or it can be a BP monitoring system. If for everything, you have a wearable device, you're going to purchase that, be it a smartwatch, a wristband, waistband, whatever it is. You're going to buy that, and you are going to hook it to the Wi-Fi, and you are going to connect it to pair it with your mobile phone, and you are just going to make sure that your device is being charged on a daily basis or as required, right? And once that happens, like those of you who are using probably Apple Watch or Fitbit would know this. Every day the data goes to the app and you can see this. So in case if I want to monitor my heart rate or my daily activity, all I have to do is buy a smartwatch, right? But what if I have to buy monitor these things in a deep sea diver, right? It's the same problem. I'm going to monitor the heart rate, the activity of the person, the respiration rate of the person. But the challenge is like how to get close to real time data when the person is actually doing a deep dive there, right? So how to actually collect the data, send it in the real time, and how to give feedback to the user in case if there is a challenge they are facing and all that. So this is all the kind of projects we are taking into consideration, where there is a severe limitation in terms of deploying the traditional IoT frameworks. So when we talk about when we started approaching this problem, we started talking about like how to make the end effectors. So those of you who are not familiar with robotics, effectors in robotics term means the end devices that actually interacts with the real world, right? Now, when I'm talking about robotics, you might think about probably Chitti the robot in the Rajinikanth's movie, or probably Shah Rukh Khan as the robot, right? It's usually not like that all the time, right? Or when if you just Google robotics, you might see those big arm just picking and dropping or sorting out things in the Amazon warehouse and all that. Robotics is not just about that. So we can, like, in case if you can integrate an actuator and a sensor, and you can like collect some data and you can give feedback in the same framework itself, you have a very simplistic robotic framework in there, right? If you so what we started doing is that if we have to come up with sustainable end effectors, how can we approach this problem, right? So one approach we took is the soft robotics. So for soft robotics, particularly for the grippers, so what we try to do is the gripper is nothing but the end effector here, right? So when we are talking about the grippers, like there are different approaches when when they are trying to in, integrate gripper for their problem, right? So they can probably use it for agricultural applications, industry applications, or healthcare. Grippers are very important in robotic assisted surgeries and so on, because they want to have high precision and all that. In this work, what we try to do is a very low cost framework for the soft grippers. So we came up with those stretchable sensors that can help in measuring the pressure sensitivity, and we were trying to integrate it as part of our gripper, where we collected data along with multiple objects in such a way that it knows whether it is holding an orange or a tennis ball, basically, right? This in this work, the big picture idea here is to have these stretchable sensors as part of a electronic skin or as part of existing frameworks already. So such that like in any existing gripper or a glove, we can just integrate it as part of it. That's the big picture idea of this. And we try to because we are relatively new to this, we try to experiment this with the flexible resin, the silicon rubber, and different materials, basically to see how soft can this sensors and also the gripper can be. In our other work, we try to integrate haptics for giving the feedback through the soft effectors, right? So haptics is nothing but, for those of you who are not familiar with the topic, haptics just means giving some vibrations in a specific intervals, right? So for example, I don't know how many of you are from the Nokia age. I was fortunate enough to have used one of those old brick type Nokia phones. When the Nokia phones vibrate, the entire house would know, right, that there is a incoming phone call, basically. So what we try to do is In those things, in those type of cell phones, in the older cell phones, if you see, the vibrations were used to be based upon the ringtone that you said, right? Kind of thing. So that is what we are trying to mimic. Just that we are trying to do it as part of the soft effectors itself. So imagine wearing a glove, and in case if you are probably coming across any harsh environment, it gives some feedback immediately, right? So it gives a vibration in case if there is a problem. This one particularly we try to integrate it as part of a assistive living framework, where we are trying to integrate this as part of a sign language a framework, where people who have limitations in communicating it to us as such. In our other work, we are try to develop soft effectors for amphibious robots, where the challenge here is this particular. Uh, if you can think of rabbits or frog and all that, they all have this hind leg, right? So basically, what it does is it helps the frog or the rabbit to actually get a jump from one place to another. At the same time, for frogs or amphibious animals, it helps in swimming as well. So it has to be strong, and at the same time it has to be flexible or soft. So the challenge here is to integrate these two as part of one framework. So our this particular work has recently got accepted in the ICRA, the flagship conference for robotics. We are going to be presenting a poster there, and we are further working on this design to see how we can actually mimic everything as part of the soft effectors itself. So for those of you, in case if you are listening, first of all, if you are interested in this topic, I would advise when we are talking about all this like modeling and all that, start with something as simple as the 2D modeling. Like we all have free access to Agludo, that's a physics-based tool. You don't even have to purchase any expensive licenses. This really helps in understanding the physics part of it. So how firm the spring should be, right? Or how many rotations should the motor actually have to actuate the entire limb, basically. All these like and how many screws do you need, where do you need those screws, all these different like actual basic physics concepts, the load balancing and all those things we will understand in the 2D modeling itself. Once you are comfortable with this, then we can go with the 3D modeling. Here particularly we use Fusion 360. uh, I believe as students, it might be easily available to you all. So in 3D modeling, you actually can choose the layers, the material you want to model, and all those things. After everything, we can actually initiate the 3D printing. And in 3D printing itself, there are several steps like slicing, curating, and all those things. So uh, this is a process basically. And if you are interested, if you are willing to learn more about this 3D printing stuff and about the soft effects or the soft robots, I would strongly encourage, please do look out for any of the makerspace or a fab lab in your university. It would they would definitely have at least one or two 3D printers, right? You can take it up as part of your any course projects, or you can get involved with the faculty who's actually working on that research. So this is a very interesting domain, and there is still a lot of things that can be done as part of it. And it's so exciting when you actually design something and you see the physical print immediately, right? Or at least in a day or two. The reason I'm saying this is I come from VLSI and FPGA background. So when we talk about VLSI frameworks, you do all this like transistor level modeling, and I have never done a tape out completely, right? It goes out to the industry, and they kind of like make all those changes, and finally when the PCB design or the ASIC tape out comes to us, it takes forever and ever. And this one, the 3D printing stuff, it just takes like probably in like 2 or 3 days, as I said, to actually come up with a design and print it all out. So this is the recent exciting work that we are doing. And I'll also talk about the other smart systems as such that we have been developing. So here you see the remotely operated vehicles for our frameworks. This one is a float. This doesn't really move around. It's more like a float. So it takes it can just like not sink basically, and it can just take a swim around, but it is not going to actively use any effectors to swim. It will just move along with the water currents, right? And this is equipped with 3 layers, and it has all these batteries and everything which can like communicate the data to us as close to real time as possible. These are the lightweight turbidity sensors that I was just talking about early in this presentation. So here you see the probe and all the electronics are associated with it as well. And this one is the underwater ROV model that we designed as part of our 2022 robotics team. And actually, the bio-inspired designs, we started approaching it after developing this one, because this one, as you see, there is in this 3D model, there is all these PVC pipes and the thrusters that actually helps in navigating this one, right? So when we are trying to collect the environmental data with the help of this one, it's not possible at all, because as you know, like you can imagine the boats, right? The electric boats. So as soon as you switch it on, it is going to have a lot of noise created, which basically creates all those waves in the water, right? So when you want to collect the data as it is intact to the environment, it's not possible with these frameworks. So that's why uh, once actually when we started doing this in started with this in 2021 is when we were like, okay, this is not possible through the traditional robotic framework. So we started approaching the biomimicry and stuff. Another very exciting work that we are doing is the FPGA-based drone controls. So, for those of you who are from EC background or who has access to FPGA boards, FPGAs, the field programmable gate arrays, are a powerhouse of computing. All right, they have so many logic blocks embedded in it. I'll tell you, in 2012, Intel released a FPGA board with 4 billion transistors in it, right? So it's just the computing capacity is just increasing forever and ever in these tiny little uh, boards. It's not as tiny as you would expect because you guys are working in nanotech. I shouldn't use the word tiny, but these are small little boards that can be used for basic binary conversion, right? In your university, you will definitely have access to these FPGA boards. FPGA boards from Xilinx, Ultra are the most commonly available ones. If you are looking for a career or if you are looking to improve your resume in your projects, I would strongly advise integrate the FPGA instead of a microcontroller or a PC or a single board computer for actually collecting the data. The reason is this one, the research is constantly evolving, and doing integrating these FPGAs as real-time projects is very uh, helpful in improving your resume and so on. Because when we actually teach the students in the undergrad, traditionally we just teach them to implement an OR gate or an AND gate and just use these switches in here and blink an LED or something, right? That is like actually uh, very less usage of this powerhouse of computing. So here we are showing a demo of how we can use the FPGA boards to actually control the drones. So we use lightweight drones like the Tello drones, and we use the FPGA as a joystick instead of the PC or the actual joystick that comes with it. So this was particularly helpful in like making a low altitude uh, motion for the drones. And this work also we have submitted to the ICRA conference. So when I'm talking, if you're interested in like learning more about the demo as such, you can just scan the code in here. So far we are talking about we started with the end devices, and slowly we started talking about the framework as such, like the ROVs or this FPGA based devices where we are doing all the computing. So these are like the different applications we have been working on recently. There is also when I started my research, I was working on Internet of Medical Things. So where we are using all these IoT frameworks for monitoring healthcare of a person. So be your smartwatches, your waistband for, or your mobile app, or your cameras for using for collecting data points basically for various applications. In this work particularly, we developed an IoT controller for monitoring mental health parameters. So what we try to do is, there is a smartwatch already collecting the heart rate, activity data, and the ambient sensing, basically, right? And we came up with a framework for eye event tracking where we put the electrodes on different on four corners of the glasses, where we can monitor the eye activity, how fast it is moving, and so on, right? So all these data points are sent to the IoT controller, based upon which, in case if a person is feeling anxious or if the person is not feeling normal, it can help in like giving the feedback through the smartwatch, or through the ambient controller, or through the audio perspective. So we try to integrate different methodologies to give feedback in here. And this particular work we published in the ICC in 2020, where we used IoT for all this data modeling. Like we came up with a Bayesian based model for this. And this was particularly helpful for us to understand how to integrate different parameters as part of this and give feedback, basically, right? So this particular work of giving feedback, like sensing something and giving feedback in terms of the psychology based data, is nothing but affective computing. So for those of you who are trying to branch out to different domains as such, you can definitely look into affective frameworks. So affective frameworks is like, you can think of those meditation apps or mobile app where it says like calm down, like in case if you are trying to meditate, or if you're trying to get into a yoga routine and all that, there is someone like constantly telling you, right, like calm down, breathe, and like have a sense of your environment and all that. It's kind of the same thing, but we are trying to integrate the smartwatch or a wearable tech along with it. So what it means is that we are trying to automate the whole process of where we are saying that in case if there are any parameters that are detected that shows that we are not feeling normal, the app or the audio can go on its own. This was particularly helpful for the assistive tech research that we have been working on, because there are still older folks that needs lot of assistance in terms of this, right? And another work in terms of the uh, this one is, uh, people talk about when it comes to assistive living, people talk about fall detection and so on. But okay, if you have if they are experiencing a fall, or if they are experiencing any type of major events, basically, right? It can be just that uh, for people those who have Alzheimer's just forgot about something, about their whereabouts, or those who are in early stages of their dementia, or who has amnesia and all that. So the, understanding the emotion of the person is very important, because when we talk about older folks or elderly people, they have been in their best active stage at some point in their life, right? And for most of them would be veterans, so who would be who would have been able to manage their life on their own much effectively. Now, to just admit that they are going through something takes forever. And it is important for us to use our knowledge in technology to come up with all these like different frameworks that can help in the that can help the older folks to easily manage this. I strongly advocate this because and especially building an equity in terms of the assistive tech, because when we are talking about all this assistive tech or like a smart wearable technology and all that, it is mostly in the areas where people can afford, right? There are still older folks or elderly people who don't have access to even the basic facilities. So it is important for us to build this equity. So that is why we are approaching these problems with low cost frameworks that can be easily integrated in their day-to-day activities. So we talked about the end effectors, we talked about the smart systems of like how our frameworks where all this data computing is happening. So a little bit about like what it takes to actually do this data modeling, right? So when we are talking about the whatever was happening in the cloud that I showed, so when we are talking about the data modeling, here is one example. So this one, we are trying to monitor the tiny fish movement. So the idea here is to come up with a bounding box for the moving fish as such, right? So all these rectangle boxes that you see are trying to detect the fishes basically. So what is the main challenge is that like when the target object is big enough, you can easily understand that. Here we are trying to come up with something that is as small as possible and as efficient as possible. So we need to we need to ignore the dust particles and so on, and we need to just target the fish area in there, right? So this one is a very interdisciplinary collaboration where we can like help all these folks from sciences, biology, pharmacy, and so on in monitoring the fish movements as such. So when we came up with this solution, we had to run this algorithm right at the monitoring edge itself, which means we are looking up at integrating the neural networks right at the monitoring edge itself, right? So this is like one such device that we thought about, where we can actually place the camera and the computing framework inside the water, or at least close to the fish tank as such. So that's what we are trying to do in here. And this particular work, we are trying to detect what is the native species and the invasive species in here as such. And when we are talking about species distribution model, this is a work on the mosquito habitat monitoring. So mosquitoes, as you know, tend to evolve in a when the temperature and humidity is of a certain level, right? NASA has this extensive research going on globe. They have this tool called Globe, where they are collecting all these data points from the satellite images, through which they say that at this temperature, at this humidity level, or in this particular environment, the mosquitoes would there is a possibility of a mosquito hotspot in there, right? So when this happens, it is easier for them to keep track of any outbreaks of malaria, dengue, or such kind of mosquito-borne diseases as such. So what we try to do is integrate that globe data from the database into the monitoring side itself. And we try to come up with a random forest based model where we can like take different parameters into consideration and come up with the data points. So what we are trying to do is use all this different data to come up with a binary prediction, basically just a 0 or a 1, right? And in this particular example, we are showing like what is the percentage of chances with respect to the cloud cover. So if you are interested in this work, I would strongly encourage you to look up at citizen science projects from NASA or ISRO. So, citizen science projects are basically the scientists are trying to collect data from different collect data across the globe, right? And for every single problem, we cannot put a satellite up there, or at least we cannot just rely on the satellite images. We need something to actually collect the ground truth, basically. So citizen science projects are basically, you can think of, there are a lot of ISRO, NASA funded citizen science projects for measuring the water level in the lakes. So if you find if you go to any of those lakes, and if you see a scan the barcode or something like that in a board in there, which means that it is part of the citizen science projects. And they are trying to basically collect the water level, the cloud cover, like how clear the clouds are, because they are indicators of the pollution. What is the air quality parameter? So for the monitoring the air quality, here in Texas, they or all over the US, they have been sending out like low cost air quality sensors that can be put as part of a house or the schools, high schools, and so on. So where they are trying to collect that as a parameter, there is a big dashboard where all these parameters are basically stored as a data trend to show that, like for example, in India, we can say that the air quality probably might go bad, especially in the winter times to after Diwali, where there is like lot of crackers and so on, or where we all know, not very long ago in Delhi, there was the air quality was really bad for the whole of January and February in one of the years, right? So examples like that, where we can like actually use a citizen science data, citizens as the scientists there, basically. So all you need is a mobile phone, and if you can just look up at NASA Globe, that is that is a database. You just have to sign up once, and you can just contribute to any of the existing researches that has been going on. So with this, I will wrap up. In case if you are interested to learn more about our research or interested to work with us, we are actively recruiting master students. We are non PhD granting, but very soon we are working on some grants, so we'll be ready to work. Ready to recruit some postdoc scholars. So if you are interested at all, get in touch. I'm also very active in LinkedIn. I would like to hear from you guys. Thank you. Any questions?
Thank you very much, ma'am, for your informative presentation. Now I would request to all the participants, now floor is open. If you have any queries or any doubt regarding the presentations, you can ask directly to our speaker.
Hello, ma'am. Good evening. This is Sanjay.
Hi, Sajay.
Yeah. So, ma'am, thank you so much for your nice talk. So, basically, my question is related to the underwater imaging systems. When we build,
Mm-hmm.
so basically, I think for the underwater imaging, we need to put the device at the deeper level inside the ocean or something else, the places. So, and they're having in a very high the water pressure. So, to build the system, which critical parameters we need to reconsider that to basically protect the device and all the data? Uh,
That's a very good question. So, I'll give you two different scenarios here. One of the things is that they are collecting, so basically, those floats that I talked about, float, or they also call it as sondes. So, those big devices, they are basically like a big PVC tubes that are equipped with all these sensors, right? So what they do is they have like some of them have cameras as well. They just integrate it as part of these sondes or floats, and they send it out across, right? There is a SD card attached with it, and it just takes the data, and they put it out for like 10 days, 30 days. Some of them even stay up for 90 days, depending upon how expensive the sondes or floats are. And they just keep collecting the data. So like I work with someone who works for the government, and they say that they just put it out there and they'll just mark the date, right? After like 30 days or 90 days, depending upon when they have to collect it, after that time, they will go and collect it, and they will use the SD card in it for it to actually do all the data analysis and all that later. This is one method where this is, first of all, they are using it for lakes, so there is not going to be like a major uh, any of major drastic changes or anything. It's just going to float around the entire area, right? And it is going to it is for non-critical situations, I would say. And there are situations where they actually use it for, like as you mentioned, for oceans or for the deeper part of the lakes, like for the larger lakes as well. So where they have to use it for all this like invasive species monitoring and all that. So for in that example, I'll give you one case study for this. They are trying to come up with a framework for monitoring invasive weeds, right? So invasive weeds, the problem is that like there is this great salvinia, which is probably like around like 5 to 6 centimeters of overall length, and the top part of it is like for 3 to 4 centimeters, right? The leaf part. It has a very thick, velvety kind of leaf structure, which it basically, once it starts spreading, it will be like a blanket and it will just block the sunlight for the entire lake. Texas has lost several water bodies because of this great salvinia. They don't know how it comes, but once it comes, it just like ruins the whole water. So it only takes like 4 to 5 days for that great salvinia, that invasive weed, to grow across the entire lake body. So in this situation, they cannot just put a sond out there and they can just let it be, right? So in case if they think that there should be like some parameters associated with it, they need to come up, they need to closely monitor it at least on a daily basis, because even 1 or 2 days delayed might make the great salvinia spread across the lake, across a water body basically. So this is mainly depending upon the situation, you can depending upon the case study that you are approaching, you can like fine tune it. In our research, so far, in the underwater systems, what I think is very important is, as you mentioned, like the along the water column, basically, right? Along the different altitudes, how to precisely send this framework. Because if you're just going to send it across the water surface, it's a lot more convenient. Or if you need something to penetrate to the surface, like throwing a missile kind of thing, faster, right? That is also easier. But if you want something to move along like 1 feet at a time or like 2 feet at a time and then collect those parameters, that has been very challenging in this underwater research of whatever projects we have been working on. I hope I answered your question,
Yeah,
Sanjay.
thank you. Thank you. Yes, yes, I got it. Thank you.
So, any other question from the participant side? Okay, so ma'am, actually, I have also few queries. If you allow, can I ask? Okay.
Yeah, sure,
So
sure.
actually, we also work on IoT-enabled circuit.
Mhm.
Actually, we do the gas sensing and transmitting the data via IoT on Android mobile application for the real-time monitoring of gas concentration of a
Okay.
particular gas exposure. And what the challenges actually during this what we have faced actually, major challenges we have faced related to the data transmission, because when we transmit the data via Wi-Fi module on the cloud and from cloud to Android mobile application, it takes 10 to 15 seconds. So if we are focusing on real-time monitoring, so somehow it will lag actually. Somehow, if it is changing continuously. So if it is continuously changing. So we face the problem to real-time monitoring actually. If let's take an example, if the gas concentration actually exceed in 500 ppm, and immediately if the gas exposure is turned off and it comes down to 10 ppm, then this change occur after 10 to 15 seconds. So then buzzer during this time actually buzzer will be on because gas concentration was already exceeded. So buzzer will be on for 15 seconds. So that's the problem actually we have faced when we have real-time monitoring done by a IoT circuit. So is there any suggestion? Can we actually remove this
Yes.
problem?
For situations like this, try to look into the edge intelligent part of this one. So instead of actually sending it to the cloud and this one, there are like after COVID they stopped the production, but there is like Intel has this neural computing stick, even the Raspberry Pis or the microcontrollers that you have access to, you can
Yes,
build
ma'am.
the data model right at the monitoring edge itself. This is very interesting. One such problem, I have a non-disclosure there. I have helped a team on a similar problem like this, and what they eventually we tried to do there was make the buzzer everything or the feedback everything connect in the same system itself, right?
Yes,
So
yes, ma'am.
what I'm trying to envision here is if I'm giving this one device, if I'm giving this one sensing probe to you all, and everything, all the computing happens in there. So even like there is the transmission, sorry, the uh, time required for the data transmission, all that can be saved. Actually, 10 to 15 seconds that you're saying seems to be very interesting for me, because what we worked on had at least a minute delay. And my collaborator, they were saying that like if it goes beyond like 20 to 30 seconds, means we are not cutting the mark there, right? So everything when it is connected there, and when you already uh, probably please start with this, like whatever the current framework you have, you can build the data modeling in there using any of the machine learning algorithms, whatever you are using, and try to integrate that in the microcontroller or the single board computer that you have. So in that case, as soon as like you get something above the threshold or below the threshold, within like 3 to 5 seconds, you can your whole model can just analyze that one and it can trigger it. It won't take more than I would say like in the eventually when we came up with that framework, it was about like 10 seconds, I guess. And my collaborators, they wanted to like fine tune it more and all those things. So that is definitely possible. But uh, I would advise like it's great that you are already like having this whole Android model and everything. Try to bring everything to this and use that Android model only to give the final feedback. So, for example, in case if this buzzer goes off like 20 times today, right, that can be stored as a data point for later modeling, but not send everything through to the cloud immediately. So that would really help.
Okay. Actually, ma'am, we have also provided the history pages in our developed Android app. So that's why we have tried to transmit the data via cloud. Because if we are providing history pages for the user past exposure history of weekly or past month history exposure, that's why we have tried to accumulate the data on cloud as well. That's the actually requirement.
Yes, it is. What I'm trying to say is we can like all the data modeling points when you are integrating the single board computer or a microcontroller, what you can do is the system is going to react immediately after the threshold is breaching, right? Now you say like 500 BPM or even if you say like 100 BPM, right? So as soon as it goes to 101 only, immediately you are you're triggering the buzzer. Immediate alert is happening. Okay, this one is one event. Today, so far, once it has breached. Probably, like, while testing it, you will run the simulation several times, right? So, say that we have like 10 to 20 events for today. That you can store in the cloud for later this one. So, one is the very close to real time there, where there is not much time delay, where we are triggering the alarm immediately. After collecting all this event history, then you can put it in the cloud and you can show it to the Android user, or through the mobile app. You can present it there. So that, like for example, here we have the security monitoring systems. I'll present an example like that. Like where in case of in the window there is a harsh, like if something there's a harsh force, or like someone is trying to break in, we get the alarm immediately, right? Within like 30 seconds or within like 1 minute time, there is a alarm going on, and there is the if the alarm is not switched off within like 2 minutes or so, the nearest police station is alerted. It is very important in situation in houses like this, because there are a lot of people working living still in a very remote condition, right? So it is a very important one. But like when there is a false alarm, like when we switch on the security system and accidentally we open the door, or like there is a tornado alert. So basically the other day a branch fell down on the window. When all these things happen, these are the events. So in our security history, in our security monitoring system, in the dashboard, it actually says that like January 1st, 2023, there was one event. January 20, there was two events, something like this. It shows the trend for us, but we know that all that is false alarms. But in case if we have to like investigate more on that, in case if we were actually traveling and there were these events, then we need to actually like look deep into that, right? So that is a non-real time situation, and there is a real time situation, like both combined together. So that is the balance that we that can really help in a situation like this.
Thank you very much, ma'am. So any other question from the participant? If no question from the participant, so now I want to thank our speaker. Thank you, ma'am, Dr. Prabha Sundaravadivel, for an enlightening and entertaining session on IoT. We are grateful for the time and effort you took to share your thoughts and experience with our IEEE NTC Win community. Now I would request to our host, Pawan Kumar, Dr. Pawan Kumar and Dr. Sanjay Kumar, please unmute yourself and open the video. And because actually they have organized this wonderful event. So now I would request to Dr. Pawan Kumar and Dr. Sanjay Kumar. Can you hear me?
Yes, Chandravan. Yeah, thank you so much.
All right, all right. Thank you so much. Thank you all for listening. I greatly appreciate it. And thank you, Dr. Pawan, for giving me this opportunity. I hope to be connected with you all through LinkedIn, or you have my email. You can just send me an email.
Yes, ma'am. Actually, in our group also working IoT, so maybe some collaborative work we can do.
Oh, yes, please. Yes, please. We just started working on the underwater systems. We are working with some very active group in SRM, and through which we are also publishing some papers and writing some grant proposals and all that. So I'm always open for collaboration. Please do get in touch.
Sure, sure. Thank you so much, ma'am.
Thank you all. Thank you. Bye.
Thank you very much.